The 2013 calculator paper question 30. The diagram shows the ranges of travel times between 5 places labelled A to E. So we've got A, B, C, D, E. The times are shown in minutes. So for example, to go from A to B, it can take from 16 to 20 minutes. The question is, what is the shortest possible travel time from A to E? You can pause the video and attempt the question. Now, one way that we can travel from A to E would be to go through point B. And so we can go from A through B to E. If we look at the shortest time from A to B, that would be 16 minutes, and the shortest time from B to E would be 24 minutes. So to go from A through B to E would be 16 minutes plus 24 minutes, which is 40 minutes. Another way that we can travel is going from A to B, then D, E. So if we try that route, we're travelling 16 minutes and then 5 minutes and another 15 minutes. So if we add those three numbers together, 16 plus 5 plus 15 is 36 minutes. So we've gone from A, B, E, then we've gone A, B, D, E. We can also try perhaps going another way. So we can try this bottom route here from A, C, D, E. So the shortest time would be 14 plus 8 plus 15, and that adds up to 37 minutes. There are other ways that we haven't tried. I think there's just one more way actually. You could go A, B, C, D, E. But if you look at those times, that's definitely longer than, say, going A, B, D, E. So there's no point doing A, B, C, D, E. The other way would be to go from A to C, then go back up to B and then E. If you just quickly look at those times, you've got 14 plus 10, which is 24, and another 24, which is 48. All of those last few routes seem to be longer than what we've already worked out. So looking at those that we've done, it seems that the shortest possible travel time would be 36 minutes from A to E. Question 31 of the 2013 calculator paper. Ali made a rectangular prism by joining two identical cubes as shown. So we've got one cube there and another cube there. I've added in these x's, which I'll explain very soon. The volume of the prism is 686 cubic centimeters. So that's the volume of all of this. It's 686 cubic centimeters. So what is the height of the prism? Now there are a few methods that you could use to do this question. I'm going to show you one method first. If this is a cube and this is another cube, then this length here, we'll let that length be that length be x, and this length here is x. Now, so these two lengths here would be x plus x, which is 2x. Now, we know that to work out the volume of the prism, you multiply length times base times height. So we would do 2x times x to get the volume, and that would be, so we've got volume equals, let's say, x times 2x, which is 2x cubed. We also know that the volume of this whole prism is 686 cubic centimeters, so that means that 2x cubed would equal 686. And next step, working out what x cubed is, you would divide by 2, so 686 divided by 2 is 343. And if x cubed is 343, then x would be the cubed root of 343, which is 7. Now, another method that you could use to do this is, well, if we know that the volume of this whole large rectangular prism is 686 cubic centimeters, then the volume of one of the prisms, or one of the cubes actually, would be 343 centimeters cubed. So I'll just do that now. So the volume of, just looking at one of the cubes, so the volume of one cube is 343 because it's half of 686. So once again, the volume of one of these cubes would be 686 divided by 2, which is 343 centimeters cubed. Now to work out the volume of this cube, volume of the cube would be x times x times x, which is x cubed. So I'll just put that x up there. So the volume of one cube is x times x times x, which is x cubed, and that equals 343. So to work out x, it's the cubed root of 343, and doing that on your calculator, you will get 7. So we can just write 7 in that box. This is question 32 of the 2013 calculator paper. And the question is, in this pattern of squares, each smaller square is half the area of the next biggest square. So, for example, I'm going to number all these squares here. So this outside square is square 1. And I'll just mark in these other squares. Then I've got this, so the outside square is square 1, and we've marked that with a 1. The next square, which is this grey square here, I've called square number 2, because we're told that each smaller square is half the area of the next biggest square. So that means that square 2, which I'm outlining there, is half the area of square 1. And so now square 3, which is this white square in the middle, will be half the area of square 2. And square 4, again, this grey small square in the middle, I'll call that square 4, that's half the area of square 3. And the question is, what is the area of the grey part of the pattern? You can pause the video and attempt the question. Okay, now to do this question, we can work out the area of each square. Now we know that the outer square has dimensions 20 millimeters by 20 millimeters. If this is 20 millimeters, then this side is also 20 millimeters because it's a square. So the area of square 1 is 20 times 20, which is 400 millimeters squared. So the area of square number 2, as we know, it's half the area of square 1. So it would be a half of 400, which is 200 millimeters squared. Again, the area of square 3, the white square, will be half of the area of square 2. So it will be half of 200, which is 100 millimeters squared. And the area of square 4, this small grey square, will be half of the area of square 3. So it'll be a half of 100, which is 50 millimeters squared. Now the question is, what is the area of the grey part of the pattern? Now, to work out the area of the grey part of the pattern, it would be the grey square, you'd take away the, so it would be, square 2, which is the grey square, subtract square 3, which is the white square, but then add back in square 4. So I'll just put that down here. So the area of the grey part is area of square 2 minus the area of square 3 plus the area of square 4. So that will be 200, take away 100 plus 50, which is 150 millimeters squared. And that's the answer to question 32. And that's the end of the 2013 calculator paper.